they really try very hard. And then every time that you say, though, you want to, I want to ask a question. No question. You just believe us. Every time you say, can we have a little debate? I don't understand your facts. Can you explain to me? They just say, no. Al Gore says so. So we go to this next one. Is another one of the world experts. Is the
Let me ask you, what percentage of the atmosphere is CO2?
What percentage of the atmosphere is CO2? I don't have that calculation for you, sir.
Maybe you could tell us what your personal guess is on what percentage of the CO2.
I don't make those guesses, sir.
You're the head of the EPA and you don't know? You have all of these laws based on, you're going to get your staffer to tell you now. But you're the head of the EPA and you did not know what percentage, and now you are basing policies that impact dramatically on the American people, and you didn't even know what the content of CO2 in the atmosphere was, which is the justification for the very policies you're talking about?
No,
well, thank you.
If you're asking me how much CO2 is in the atmosphere, not a percentage, but how much, we have just reached levels of 400 parts per million.
I think I was very clear what I was asking, and I was very clear you didn't know.
Well, we have a problem in the West, right? It's been known that there's all this wild-ranging forest fire is damaging our homes and so on and so forth, right? Whatever the reason is, apparently the Professor Jim Hansen from NASA Goddard Institute for Space Study, by the way, you all know who he is, right? He's the father of global warming. He's the man who testified in the Senate in 1988, making a clear statement that he's 99% sure that he has already seen the global warming effect by the carbon dioxide, okay? This is telling you the level of stuff he's doing. He's presenting this talk to show that the forest fire numbers burned in the areas has been increasing, okay? And he showed data from 1960 to about 2017 or so. And this is based on a talk with children, okay? Students at the symposium in Taiwan. And I have to say that, that seems very convincing, isn't it? If you are a big authority coming from America, former, NASA director. But I think the God is angry right here, right? Something is burning. But the problem is, he's pulling such a childish sort of thing. He put actually a link to the data set where he got it from. But he forgot that the whole data set is available from 1926 or so. Why would he do such a thing, He basically, you all understand, right? He was showing you only that little part, but he forgot to show you from 1926 to 1960. Isn't that childish? Are we serious about science? And these are called scientists, right? And I'm not supposed to tell people about this? This is just a sneak preview on my own study with my friend from University of Mexico by the name of Victor Velasco. We've been looking into the forest fire statistics. This is simply just to show you that the wildfire statistics from about 1930s or so until now, and then we make a forward forecast. We analyze the data. It turns out that the data has very strong, what you call, every 10-year kind of cycle. It has also every 40 years kind of cycle. And then we train the computer using some of this algorithm called artificial intelligence to actually make some forward forecasts, just simply to show that you can do some of this exercise. And I don't mean that I already know everything, but this is just an example of what science is all about. And then we know that it's summer now, so I'm obligated to show this chart from Professor John Christie of University of Alabama, Huntsville, is to show you all this record daily hottest temperature in United States. United States has a very good temperature record, so we can go back about from 1895 until now. You can see it's been changing up and down, but then what we have now is just what it is. That's all it is, right? It has nothing to do with this. Because they tend to use that, every time there's a heat wave, it has to be global warming, right? The next statistics I'm going to show you is about hurricane. TC is tropical cyclone, the activities, going from about 1970s to now. The reason why you start in 1970 here is because this is the satellite era where we have satellite to look at all the statistics, so it's rather more accurate. But the point is, where is the killer trend? You look at anything you want, right? Tropical cyclone or extreme hurricane, they're going up and down, up and down, up and down, right? Where is the carbon dioxide, Al Gore? And then if you look at the more relevant, the impact type, the tropical cyclone that actually land on the, come to the land and sort of cause damages. Category 1, 2, 3, and 4. These are 3 and 4 and 5 are of course bad because the wind speed is high, probably a lot more rain as well. It's pretty much up and down, really. So one other things that we want to learn is always like that. You really, every time you hear a word, no wonder they say, for example, some people worry, why am I showing so many charts? Because you know why? Words are very bad because they are able to deceive you. You have to learn them. Every time they say this and that, you ask them, where is the data? I want to see the data. My good friend from Ireland say, where's the data, right? Let's look at the data. The first data I want to look at is tornado, for example. This is among the 3 strongest. The one that is tornado that is up to 140 miles an hour kind of wind, up to 200 miles an hour kind of wind. F3 to F5. And showing you the statistics from 54 to now. I don't know. I mean, maybe they like to say global warming causing the trend to go down. Oh, no, it's not possible. It's not possible. Slide that you should see, right? On your left is the one that last year, when you are very warm on the land, you got no tornado activity at all in the May. But this year, kind of very cold in the Midwest, you tend to have a lot more tornado formation. It's just the opposite of what they say, by the way. Right? This is the typical graph they show from about 1880 to now, let's say, right? You measure that, oh, the globe is warming. If you show the relationship with carbon dioxide, oh my God, did you see it? It's almost a perfect correlation. If you plot the carbon dioxide on the horizontal axis, the global temperature on this is perfect correlation. The first reminder I want to remind everybody is that it turns out that this climate is among the most misunderstood subject. Because Al Gore, the average D student, thinks that he understands climate. My God, it's as sure as gravity. He always say that. You guys are just denier, right? But to understand climate, you need to study what? Astronomy, solar physics, geology, geochronology, geochemistry, sedimentology, tectonic, paleontology, paleoecology, glaciology, climatology, meteorology, oceanography, ecology, archaeology, history. And that's not even complete. And these guys say that if we just change the carbon dioxide content in the atmosphere, that we're going to control the whole system. It's a bit ridiculous, actually. Right? Be serious. Science is very serious. So greenhouse effect, well, I'm not going to explain it because my friend going to kick me because we study this issue very carefully. But the idea is that you added more carbon dioxide molecules, it's interact with the energy flow in the climate system, and if you have more carbon dioxide, you will tend to warm the climate, okay? So let's study this carbon dioxide. Who thinks that the most important greenhouse gas in the climate is carbon dioxide? Oh, very smart audience. It's X, yeah, it's actually H2O, really. It's water vapor, right, in all forms. In the vapor, snow, and ice, and liquid form, right? That's, in fact, half of the job. If we want to study climate change and all that, you really need to study hydrology, okay? And just to give you an example, don't mind the complexity. All the arrows is meant to tell you that, please don't get confused, but then it's to try to show you the climate is really complex, okay? And I'm going to show you, if I click all the individual components and compare the role of carbon dioxide and water vapor in the climate system, let's say who is in charge, right? So first thing we go is we keep clicking. All the blue one turns out to be controlled by water vapor. Okay, snow area, ice area, surface vapor pressure, relative humidity, soil moisture, evaporation, everything is blue. And then they say that if you just change the carbon dioxide, that you're going to get that. You're going to control the climate system. That's basically what it is. And then when you come down to water vapor, they occasionally like to put a picture like this. The one from power plant, right? By the way, please understand, you cannot see CO2, okay? Some kids from Sweden, the lady named Greta Thunberg, say that she can see carbon dioxide, actually. This is how bad it is, right? Instead of going to school to learn that carbon dioxide is in infrared, you cannot see this thing, okay? And she said that she can see CO2. So it's just a bit of a joke. I just wanted to point out that the role of CO2, water vapor, is very important in the climate system. So I'm showing you two graphs, okay? Top and bottom. The top graph is actually temperature. The bottom is water vapor, okay? And I'm showing you the distribution from South Pole to the North Pole. And then in the vertical coordinates, it's actually going from 0 to about 20 kilometers, right? What I'm showing you is that temperature and water vapor at one instant of time. Okay? It shows you that as you have more water vapor, the area tends to be warmer. As you have less water vapor, it tends to be cooler. Okay? That shows you how close a relationship of temperature and water vapor is in a climate system. And then in terms of time, at least we have two satellite measurements. The blue curve is actually showing you the temperature measurement, and then the red curve is actually showing you the water vapor concentration in the atmosphere detected by the satellite radiometer. Okay? They're pretty close relationship. Then I'm going to show you this because the ultimate things about science is about tests, right? You have a hypothesis, carbon dioxide increase. What does it do? Increase the greenhouse effect, yes? So a paper that published 2 years or 3 years ago, indeed trying to quantify this issue. And they tend to find that the last few years, you tend to have this so-called flattening of the greenhouse effect, which I will show you by this graph. From 1980 to 1991 or so, there appears to be some kind of increase of the greenhouse effect. And then by the time you reach about 92, 93, if you keep plotting the greenhouse effect, it seems to be flat, going up and down. So what this is telling you is that if you study the energy flow in the climate system, that the last few decades it's been flattening. There's just, even though the carbon dioxide is rising, it's true, that one is still true, by the way. But the greenhouse effect has been flat. So what does it tell you? It tells you that carbon dioxide is actually playing a minor role in the total greenhouse effect in the climate system, really. Because this effect of flattening is caused by two things. The cancellation between the water vapor and the cloud effects, okay? But not controlled by carbon dioxide at all. This is actual measurements. If you don't like this, look at the result from Antarctica and Arctic. They measure something called the outgoing long-wave radiation. Satellite could do those things. It's showing you something like this. So I think in terms of testing the empirical effects of what carbon dioxide do to the system, it's fairly convincing that no such thing exists. And then when you come down to global warming, just remember too, every time they say that if I have more carbon dioxide, I'm going to warm the climate by a few degrees, let's say. But the few degree in the context of a city like a Boston, I'm basically showing you the daily temperature in Boston from January to December. Okay? And then they say the global warming going to change by 2 or 3 or 4 or 5 degrees Fahrenheit, let's say, on this scale. We go from anything from 10 degrees Fahrenheit to 80 degrees Fahrenheit. And we're talking about this tiny thing that is very hard to detect, even if you allow their theoretical speculation to be true. So I want to show you this case that is very, very outrageous. What I'm plotting here is 3 curves. 2 curves is basically the blue and the red curve. They are what you call the satellite temperature measurement of the global temperature. From about 1990 something to about, let's say, present time. It's going up and down, but it's flat, right? This is what the famous thing called the global warming hiatus. It's not warming up, or the carbon dioxide is still rising. And then another data set that shows is rising is produced by NASA Goddard Institute for Space Study. The 2 satellite data is measuring something from a layer about a few kilometers up from the atmosphere. What is measured by NASA GIST, Goddard Institute for Space Study, the green curve, is from the surface thermometer data. We don't believe that data is true, of course, by the way, so we're working on those class of problems. But here I want to refer to a case by the group called RSS. They are from Santa Rosa, somewhere here. They are actually showing that curve in 2016. And then I want to remind, because every time that in science, that if you can do as many independent measurements that you can, that is becoming more interesting. I just want to remind you on the middle panel, the RSS and the University of Alabama Huntsville data agree with each other. There's a flat trend. But there's actually a third data set that is measured by another technique, okay, from a Taiwanese group. They're actually using some very special technique of looking through the atmosphere and do that sort of thing, radio occultation for people who wants to know. It actually shows satellite flat trend, by the way. So what do? We have 3 data sets, 4 or 5 data sets. 3 of them kind of show flat here, right? Because they're measuring the atmosphere. And this guy from the surface showing the warming. So is it really true that this hiatus, this so-called hiatus, you understand this, right? If the temperature is not always coming, is rising, do you actually consider this a disaster for them? Instead of saying that, hey, maybe that we are wrong, carbon dioxide is not important. Oh, no, this will shake all their foundation. They don't like it, okay? So they started to say that these are fantasy created by people like myself. Okay, so they have BBC say, what happened? What happened? We need to study this. And then you even have, sorry for the quote, but anyway, there are folks in scientific community talking among themselves saying that we're in trouble now because we cannot explain why the temperature is not warming up. So it shows you that they are worried internally. And even worse, a very famous professor by the name of Professor Phil Jones from UK was actually writing to his colleague from the UK Meteorological Met Office because they were making forecasts. They even forecast that the temperature will keep flat for about 2020. Remember this, okay? I'll make the point later. Because even forecast is showing that it's going to show flat. Because, you know, they want to show that they can predict this. Oh, we understood this thing, but it will warm again. You just wait. You just wait. It's going to warm again. And look what happened. 3 years later, RRS temperature now agree with the Goddard Institute for Space Study. So, if the data don't fit your theory, what do? You change the data, guys. Be smart. Why not? That's okay. So they were talking things like that. They're beginning to talk among themselves that maybe, you know, satellite data, by the way, is measuring something in the troposphere, like few kilometers up the air. It's actually a good measurement because they're measuring something from the vibration of this oxygen molecule that is very uniform, okay? Because it's very same amount of constant, 21% everywhere. Carbon dioxide, there will be a lot in this room, few thousand parts per million. Outside is 400, things like that. It's very good. And then now they say the surface thermometer data that has all kinds of problems is okay. So this is the summary. When the data don't fit, you just change the data, okay? So then I'm going to get into another case that is very serious. This is very serious. The man on the right or left is Michael Mann, and then the other one is the famous Bill Nye, the science guy. Celebrity. But anyway, this is concerning a very serious problem. Michael Mann is well known and associated with a phenomenon called hockey stick temperature history. This is actually a paper that's been produced showing that the temperature could not change much from 1000 AD to 1900 AD, very flat, and then it warmed up from 1900 to now, zoom it up. Never mind the hiatus, of course. And then most people are studying this flat part. Okay? I produced a paper myself. In fact, my paper was the first one ever produced in 2003. Now, I want to focus in on the blade problem, okay? Let me show you. I wrote a scientific paper just to make a point to say that we study this issue carefully. And then I want to tell you that Michael Mann was very worried about this, so he put out in the blog saying that, oh, there's this so-called attack paper. In science, when somebody criticizes your work, you'll be very, very happy if you're an honest scientist. Because according to Michael Connolly, my good friend, saying that we learn more then, right? Instead of saying, oh, this guy is attacking me, he's from denial club, and so on and so forth. So he actually blamed that, you know, I was trying to attack IPCC. No, Michael Mann, I was attacking your work, not IPCC. Really. He was so proud. He was so proud that he tried to stop my paper from publishing. He was influencing this American Geophysical Union that published that journal, Geophysical Research Letter, where I printed in 2004, calling them that I have violated copyright in my paper. Therefore, the paper shall not be published. Let me show you the problem. You can look here. It's a bit hard for me. Okay, left. Okay, from left to right, you have 3 data sets. Michael Mann 2002, Michael Mann et al. 2003, and Michael Mann and Joan 2003. And then the one to your right is my results. I try to emulate whether you can get this temperature change. This is actually the temperature change for the last 150 years or so, right? You notice that in less than 1.5 years, 2002 to about 2003, you notice that the N curve, the red curve, is what I want you to focus on. It keeps changing. It keeps going higher. Do you understand what it means? It's impossible. Under any data, any condition, the data could not change by 1 year, especially this one is 40-year filter. You smooth it out so you don't want to study the year-to-year changes, so you study the long-term changes. Do you understand? Mm-hmm. This is the part where nobody discusses. Actually, I published a paper on this to point out that I consider this case is a scientific fraud, in my humble opinion. Okay? He came back and talked nonsense again. It's very sad. How many years already? 2004? Okay? You think about it. And he was very proud. There's actually a proof that he actually talked among himself that he was so proud, Willie Soon is going to have this paper coming out, but I was so powerful, I'm Michael Mann, I'm able to stop him, okay? Because he was colluding with the American Geophysical Union Geophysical Research Letter folks about able to stop me from printing. Unfortunately, I was rather smart by that time. Actually, I've gotten all the permission to redraw the figures and to show it the way I show it. Okay? There's nothing wrong with actually taking a science. Oh, another very simple point about science. You all believe, right? If you have a data that makes something, and then you've already published your paper, do you think that we should ask them to get the data so we can check that data? Do we agree? Raise your hand.
Yes.
And do you know what is the typical answer, right? No, the dog ate my homework. No, you cannot have it. If I give it to you, you just want to destroy my idea. That kind of work, okay? I'm not joking. This is how serious science is. And these are always their side that are doing that. If they ask ourselves, Michael Connolly and Ronan Connolly, that they want our data, please have the data. In fact, every time we publish, we make sure the data is already out there, right? You don't do things like that. And then he become actually delusional. He think that he's a Holocaust survivor. He claiming that we're doing things like this.
Let me ask our director for a second, if he can go on a wide shot, and I don't know if you can get everybody on all at once, but I wonder in the midst of your lecturing to your students, whether any of you, and I'm sorry, I don't want to get too touchy-feely here, but I mean, this is what our subject is about tonight. Anybody started to cry or broken down or just had an emotional moment where you were overcome? Anybody?
Yep.
Michael, I see you nodding.
Yep.
What happened?
Yep.
What happened?
Yep. Sometimes I'll be talking about not just the science, but the denial industry and the things that fossil fuel interest did to lead us astray that are so like what the tobacco industry did decades ago to lead us astray on the health impacts of tobacco. And I'll tear up, especially when I'm talking to an audience of young people, because what a terrible injustice we've done them, or we've allowed others to do them, by misleading them on what is arguably the greatest challenge we face as a civilization. Sometimes I tear up just describing that, talking about that.
Well, one of the
IPCC is very fond of putting out this curve. They say that on your left, you have a lot of this orange line and the red curve, they are all model calculation. And then the black curve is actually observation. They can explain everything, okay? If they include the carbon dioxide. And then on the left, this blue one,
On the right.
include only the, on the right, yes. That you include only the volcano and the solar, it won't do anything because it deviates. And I have to tell you, if anybody have any understanding of statistics, this is actually an abuse of statistics. And also, statistics, I'm not interested. I'm interested in physics. You notice the unit that they plot. They always plot this thing called the temperature anomalies, which is a very strange word. It's actually a temperature deviation from some averages, okay? But if you plot in the actual temperature unit, the ice freezes at 0 degree, isn't it? The ice gets boiled at 100 degree. If you plot in an absolute unit, look, the dotted line now is actually the observation, and then the data, the model calculation is all over the place. But when you do a temperature anomaly, you actually squeeze them together, you hide it so your data look very impressive. I think rule number 1 in science is that you don't oversell your results. So in fact, they should have show this plot, but they never ever show this plot. It took them a long time until 2012, the first plot like such kind appeared. It has to be done by amateur scientists, okay, to make those kind of plot. And of course myself, but I don't need to publish paper like that. So US Global Change Research, it's actually a well-known one because they are now making a fuss out of this report, right, being something important and it's against President Trump, so on and so forth. But among the stuff that they show is that they take all those results from IPCC and they show you that, look, instead of temperature anomaly, they can plot the temperature unit in absolute unit, Fahrenheit actually. Somebody that really crazy, that they convert the unit of an anomaly, a change, to actual unit. That's how bad it is. EPA is doing the same thing. That is wrong actually, by the way. So I asked the question, where's the peer review? If, by the way, this is a phenomenon that is very serious. It's going to kill science in my humble opinion because it's not about peer review anymore. It's all power review system. And it's very, very urgent and very, very dangerous. If you care about science, you really need to speak out. So it's really true. It's from the basically anomalies. Instead of showing all those ranges, somebody foolish think that you can convert this into absolute unit, but these things are not representing that at all. Okay, I hope you understand that. And this is just another example to remind you. The model is all over the place. They have too much ice, too little ice, and all that kind of stuff. When they have too much ice, okay, I'm going to melt some of the water and throw it into the ocean. It's showing you that the climate modeling is in a very big trouble state. Then, that was long ago, maybe about 10 years ago, but now I want to show you even more recent example. This is a very prestigious lecture in JPL and Caltech. Von Karman, Theodore von Karman is a very good fluid dynamicist from Caltech. That this guy was giving a talk, and he was talking about carbon dioxide and temperature change for 800,000 years from Antarctica. But the problem is, the ice core data is showing you the temperature anomaly, the difference. Do you understand? It's showing you the difference between certain mean period. So it's a change of a temperature. But these scientists, so-called scientists in 2017, was converting 0 to 32 degrees Fahrenheit. I hope you get it, please. It's just very simple kind of goofy. It's like, I don't want to laugh at him, but it tells you that this is how delusional the whole field is. This is supposed to be an expert talking to public audience, because they want to make sure that you're more familiar, you can feel the temperature, right? You know this. But nonsense again. So this is the kind of important public policy question, right? If it's so important, why they keep pulling out all this stunt, graphical kind of stuff? Remember, I tell you, I don't believe in this persuasion business, you know. Science is all about evidence, 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 and data. So the question is, can the climate model simulate? If you think climate model is important, because that's what they use for policy, right? For the next 100 years. They say now it doesn't matter. You don't even need to validate the model, actually, they say. All I care is that if I increase carbon dioxide, it's going to warm for the next 100 years. Okay? But let me do another test. Can we simulate something simple called the seasonal cycle in the climate temperature data? So I'll show you that if you plot the information of the seasonal cycle of the temperature, northern hemisphere temperature, from about 50 years, for 50 years, you plot something on the vertical axis called the amplitude, you know how large the season number is, and then the phase, the timing of the peak, whether the summer warming and winter cooling sort of thing, when it comes. You see that the data, the climate model data is all over the place. So let's see if they can hit the jackpot. Where is the observation, right? So the observation is right here. Oh, they miss it by a lot. It's bullseye, man. I'm going to throw my thing. I'm going to throw my dart. It's going to hit somebody, right? So season is very serious. Come on. Listen what I just told you. Yeah. The climate model cannot produce a seasonal cycle. And they tell you that they know something about the climate system, isn't it? Okay? Then another serious scare that they always do is that they say, oh, the last 150,000 years ago, there's a period called the Eemian warm period. Because remember, now we're living in a period called interglacial, called the Holocene. And then 20,000 years ago, we live in an ice age, right? When the ice is about 2 miles thick in Boston and New York and reach as far south as Delaware, there's a lot of ice. So the big swing, the climate system going up and down. But every time they talk about season, every time they talk about other warm period, they use the Eemian, the 150,000 years ago, 115,000 years ago. But I want to remind you that it's completely different Eemian from now. Because now you have this solid curve. Our seasonal amplitude changed by only 90 watt per meter square. But Eemian the orbit was less circular, so it's more eccentric. So therefore the seasonal cycle is changed by 230 watts. So every time they talk about even Eemian being equivalent, like because they say Eemian, all the Greenland ice sheets melt. But that's a very different condition from now. It doesn't mean that the Greenland ice sheet would melt again, of course. And then I want to do another test about climate model. Because according to them, that if one model is wrong, that's okay. You know why? Because we're taking a lot of averages, right? This is actually a quote that is slightly embarrassing. I don't wish to embarrassing him, but he actually say it. It's by a professor of chemistry from Rice University, of course a Nobel Prize, that he say, the sobering conclusion about future warming using climate model are based on these elaborate models, right? It's usually wise to be suspicious of computer model of complex situation, but we're not talking about one scientist model. It's a number of programs give similar results. With that, let me challenge Professor Ko that I ask you to look. If I have all this bunch of passenger jets, do you want to know what the average passenger jets is? And if I show you, would you go on it, right? So it's mean that if you average all the result that is wrong, it doesn't mean that you're going to get it right, right? You're going to get it more wronger. I don't know what it is. Here's what the average passenger jet look like, right? So I don't think we want to take that jet, right? I hope we can send our go on that one. So it's a very simple proposition. If you really think that you can solve the problem like that, you give me a faster computer, right? But I want to point out that there are many follies. Just two examples to show you the problem of current day, today, 2019. What kind of problem we have in climate model? Here's one example. The first example is to ask the question, how well can the GCM, which is the global circulation model, which is the global climate model, right? How well can it simulate cloud structure? On your right is observation. On your left is GCM, right? The computer model. It really don't agree too well, isn't it? No. Right? You cannot simulate the cloud. You're going from 90 South Pole to North Pole. You go vertical height, right? From surface to basically high up in stratosphere or troposphere, right? It's very bad. And then you ask a simple thing. How about sea surface temperature? More or less similar. If you compare, this is actually a calculation, and then you compare with the difference with the observation, you can see that large part of the Pacific Ocean and Atlantic Ocean are cool by relative to actual observation for 5 degrees Celsius. That's quite large, by the way. So for climate model, I have very simple proposition. That most of the time they got the right result for the wrong reason. And then people like to say GIGO effect. The well-known GIGO effect is garbage in, garbage out. For me, that's not a problem. If it's garbage in, garbage out, I just ignore it, right? It's garbage in, gospel out is the problem. I'm very far near the end now, so please be patient. The thing I want to show now is basically about sun-climate connection, which is my area of study. The picture is just to give you the essence that the sun is powering all the energetic in the system. The typical story how IPCC would say sun is not important is to show you a graph like this. They use a concept called radiative forcing. According to them, carbon dioxide gives you 1.82 watt per meter square over the last 260 years. And then the sun gives you only 0.04 watt per meter square. Game's over, right? Really, they win. I clap hand because if this is true, if this is how the climate function, is to look at the change in the system all the time and not even think about season. This is why they avoid season, okay? And that's the reason. The same information, you can plot it like this. Because the sun is indeed the big giant gorilla in the climate system. This is actually a very nice picture of the sun in X-ray taken by some colleagues from my workplace in X-ray. So to finish off, I want to show you another way. Those that came and saw me last night at the library in a church in Woodside, California, that I show a way to study sun-climate connection, which is to say that because the thermometer data is very confused, if you take the urban data, you don't know what it means, so you take some rural station, so you study that to see whether there's any implication of the sun effect there. I think I show that there is some effect, and we have published paper on that. This is another way to look at it. So my proposal for tonight is to say that if you want to study the sun effects on this climate system, you better don't go and study the temperature during the night, isn't it? Am I right? So you study during the daytime maximum. That's basically the question. I think I should skip a lot of this slide, but I want to show you a bottom line. It's not a good idea at all to study the sun, the temperature during the night for the sun effect. Because at the night, you tend to form this thing that there's a cold stuff near the surface and the warm stuff. So you have what you call a boundary layer. So the atmosphere and the surface are not so connected because the thermometer is sitting on the surface. During daytime, it's a lot more easier to study this, right? Because it's more connected to the surface. Okay? So it's really an amazing simplicity. It's just something in the hunch that I say. You study the sun effect during daytime maximum daily temperature. If actually not so cloudy, guess what happened? You might be able to see something like this. The blue curve is the temperature maximum, the daily temperature maximum from the United States versus the solar irradiance, the red curve. If you don't believe that, you also can see that in Canada. If you don't believe that, you can see roughly of that picture in Mexico. Okay? And then finally, because the metric that I measure is called the solar irradiance, it's actually giving you information about the sun's incoming radiation more or less near the surface, more or less near the atmosphere at the top. There's a basic problem that we have a problem because this is the hardest science problem for climatology, which is to understand cloud. What does it do? What does it change more? Because in cloud there's so many types, that sort of thing. So do we have evidence to see that the effect of the sun at this upper atmosphere reach all the way to the surface? That is extremely hard to find the data. It turns out that I was able to find one set of data, okay, that shows that the radiation does reach the surface. If I plot some of the temperature data with the ground solar radiation, it shows some kind of correlation, similar picture that you cold from this period, you warm 1930s, 40s, you cool in the 70s, you warm up again, okay? So my takeaway message tonight is this. There are simply no experimental data to support the view that the Earth is changing in a very strange way or dangerous way. By carbon dioxide, by the sun, by whoever, And then one thing that we are sure, carbon dioxide is just a big player in the climate system. So the idea that you can have this carbon dioxide knob, that turning up and down is just an illusion, right? Because they imagine that this is a climate knob, that you just adjust the thermometer up and down. I would say X, right? Basically not true. And then my third point is that the sun is, in my humble opinion, is primary driver of climate change and one should study as much as possible. Again, I do not make the claim that we have found the evidence. I'm merely showing you that there's a lot of interesting hint and one should study it and understand the exact way in which the sun affects the Earth system, including sea level change, all this other stuff. And then you have to remember, climate model, that famous thing, the tools. They actually come at tool. I say it's so misleading. It's really not like knife at all, where you can use to chop, you can do so many things, including killing people. You can do so many things. This climate model is almost useless, in my humble opinion. It's supposed to be some kind of a pedagogical tool, some tool to learn, But it's not for forecasting at all. It's simply not ready, right? Because they cannot represent a lot of this physics and chemistry and all this problem. That's what the problem with climate model. It can never be used for public policy, no matter how many people say about it, no matter what the Supreme Court is saying. This is my last slide. My last slide is to quote a good friend of mine by the name of Professor Richard Lindzen, retired already from MIT because he's a bit fed up. He needs a rest. He really said that this problem is rather serious, really. He said when the historian, what historian would definitely wonder about in the future century is how deeply flawed logic, obscured by shrewd unrelenting propaganda, actually enable a coalition of powerful special interests to convince nearly everyone, except lucky few like us, right, in the world that carbon dioxide from human industry was a dangerous, planet-destroying toxin. It will be remembered as the greatest mass delusion in the history of the world, that carbon dioxide, CO2, the life of plants, was considered at times to be a deadly poison. Okay, I finished. Thank you.